Solve the right triangle. Well, first I'm going to determine which angle is the right angle. It looks like it might be angle B here, and I'm just going to verify using the slopes of the sides. So the slope of AB is up 1, right 3, or 1/3. And the slope for BC, down 1, right 3, or -3. So that means segments AB and BC are perpendicular, and we have a right angle here for angle B. So already, measure of angle B equals 90 degrees. Okay, now I'm going to need to find some side lengths, and we're going to have to use the Pythagorean theorem for that. Remember, each side here that's not horizontal or vertical can be made into a right triangle. So there's a right triangle for AB, and so I can say AB squared equals 1 squared plus 3 squared, because the right triangle is 1/3. And that's the same thing as 1 plus 9, which is 10. So AB squared equals 10, and that means that AB equals the square root of 10. If you want a decimal form, you can find the square root of 10 on a calculator. So 3.16, I'll just say 3.2. Remember, these squiggles mean approximately 3.2, and it's a rounded estimate, really. Okay, now I'm going to figure out side BC, and that is, let's see, down 1, 2, 3, 4, 5, 6, and then right 2. So it's 6 here, and then 2. So I can say BC squared equals 6 squared plus 2 squared. And 6 squared is 36, and then plus 2 squared, which is 4, which is 40. So I can say BC squared equals 40. And that means BC equals square root of 40, positive square root of 40. And on a calculator, .32 or 6.3. Okay, so let's go ahead and highlight some of these. Measure of angle B was 90 degrees. AB is square root of 10, or about 3.2. BC is square root of 40, or about 6.3. Now let's find AC. AC squared is, and it's down and then over. So it's down 1, 2, 3, 4, 5, and then right 5. So AC squared is 5 squared plus 5 squared, which is 25 plus 25 equals 50. So AC squared equals 50, which means AC equals the positive square root of 50. .07, we'll just call that 7.1. Okay, so AC is square root 50, or about 7.1. Now all the sides and one angle are solved for. We need to solve for the two other angles. So I'm looking right now at this angle A, and let's see, this is actually getting kind of marked up, so it's a little hard to see. So what I'm going to do is I'm just going to use, say, the sine ratio of A. And the side opposite from A is actually this BC. So it's going to be BC to AC, which is the hypotenuse. And that is, I'm just going to use the decimal estimates or rounded answers that we got from before, 6.3, to 7.1. So that means A is going to be the inverse sine of 6.3 to 7.1. I'm going to use a calculator for that. So second sine 6.3 divided by 7.1, close parentheses, 62.5 degrees looks like. Okay, and what we're doing here is we're doing rounded answers, and so it might be that your answer might be a tenth or two off an answer that's given for a choice, but you'll just have to make that decision. Like say, for example, if this were multiple choice and the option was measure of angle A equals 62.3, I would probably choose that as an answer because 62.5 is awfully close and there may be some round off error there. Okay, so that's measure of angle A. Last angle to solve for is measure of angle C. And we already know the other two angle measures, so I can simply say measure of angle C is 90 degrees minus 62.5 degrees. And that is 27.5 degrees. Measure of angle C is 27.5 degrees. Okay, so now we've solved for all three unknown sides, all three unknown angles. Let's review the process. There were a lot of steps here, but it really wasn't that complicated. We found out the right angle by comparing slopes. Then we used the distance formula or Pythagorean theorem to figure out the three side lengths of the right triangle. Then we used inverse trig ratio to find the measure of angle A, and then used the triangle sum theorem to find the last angle, measure angle C.